Thanks for tuning in to the Oxygen Alliance YouTube channel where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello, everyone, and thank you for joining us for week 17 of Concentrator Talk, brought to you by the Oxygen Alliance. My name is Amarpreet Rai, and I'm pleased to be hosting the Concentrator Talk today from New York. I am joined by my colleague, Timothy Matonga from Lilongwe, Malawi. And for those of you that may not be aware, Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time to discuss different aspects of oxygen concentrator assessment, use, and maintenance. We are joined today by technicians from OpenO2 and Sanrai. So we have Kulwinder Singh from Chandigarh, India. We have Mwawi Lungu from Lilongwe, Malawi. We have Paulina Mahosho from Johannesburg, South Africa. We have Mteto Sinjani, Cynthia Chikomoni, and George Ikwanga from Lilongwe, Malawi. And with that, we will get started with our first question. I am a technician at a certain private hospital. Currently, there is a high demand for oxygen at our hospital due to the outbreak of the new COVID-19 virus variant, and we are running short on oxygen concentrators. Lately, we have been buying additional oxygen from our local suppliers, but due to the high demand of oxygen across the country, they are unable to give us the oxygen cylinders on time. I just wanted to know if it is possible to use one of the oxygen concentrators to fill the empty cylinders. Mteto, if you could answer this question, please.
Thank you, Amapri. So an oxygen cylinder stores oxygen under a certain pressure. Important example, a pressure ranging from 2,175 psi to 2,900 psi, depending on the size of the tank. So oxygen cylinders are filled with oxygen at high pressure because gases have larger intermolecular space, and that makes them to be easily compressed under application of high pressure. Which enables the cylinders to be filled. So just to come back to the question, it is not that straightforward to fill oxygen cylinder using an oxygen concentrator, since an oxygen concentrator is not capable of producing highly pressurized oxygen. So the highest pressure produced by a regular oxygen concentrator ranges from like 20 psi or less. So this makes it a low chance of compressing the air into the cylinder. But this does not make it impossible. So all you need is like an oxygen refill machine, which is a separate unit designed to take in oxygen from an oxygen concentrator. So the unit contains a compressor that is used to pressurize oxygen coming from an oxygen concentrator, and it fills the cylinders. So the kind of cylinders refilled by this machine, the one you can see on the graphics, are very small and mostly used in an emergency compared to the traditional large-sized cylinders. So what we see in the graphics there is at the bottom there's like an oxygen concentrator, and then mounted on top is the Invacare home fill machine, and then you plug in the cylinder itself. So in some models like this one, the Invacare, the home fill machine take 1.5 hours to refill the cylinder. So it was also just important to point out that oxygen refill machine are 3 times the cost of an oxygen concentrator. Yeah, thank you, Amapri.
Thank you, Mtedo, for that answer. We have a poll question here. And Mwawi, if you would be so kind as to explain how everyone can access the polls as I launch it, that would be great.
Yes. So if you are joining us from your computer, if you go to the bottom right of your screen, the icon on the far right is the activities button. So if you click on that, that will bring up a window where pause is listed as one of the options. If you are joining us using a mobile phone, you also go to the bottom right of your screen and then you click on the menus option. From there, a window will open where the activities button is one of the icons listed. So if you click on the activities button, you should be able to access the pause option.
Thank you, Maui. So our first poll question is, have you ever come across an oxygen cylinder home filling device? And we'll give it a few seconds for people to answer. And while they are, I know Tato showed us the Invacare device here, which looks as the graphic is showing. There is also a DeVilbiss home fill option, and I believe Philips has one as well. These are all meant to work in the same way, where you have a piece that attaches on top of a concentrator, typically a higher flow concentrator, so a 10-liter device or more. And then they take quite a bit of time to fill cylinders. So they are really designed for the home care use. But of course, in emergency settings, anything can be helpful. And with that, we have all of our questions, all of our poll answers that have a no. So these must not be very, very common. So we will move to our next question. And our next question is, can a dirty exhaust muffler affect the performance of an oxygen concentrator? And Kulwinder, can you please answer that question?
Thanks, Amprit. So yes, the dirty exhaust muffler will affect the performance of the oxygen concentrator. So oxygen concentrators have an exhaust muffler that is used to reduce the noise produced by the oxygen concentrator during the wasting stage or the purge out stage of highly pressurized nitrogen gas. The exhaust muffler in the concentrator is connected to the waste valve of either the rotary valve or solenoid valve or a four-way valve, depending on the model of the concentrator. So when the exhaust muffler is very dirty or contains debris, it can lead to blockages which may result in high pressure buildup in the system. This also means that not all the air that is supposed to be purged out will be purged out of the concentrator. So high pressure builds up in results in the reduced oxygen purity at the patient outlet. If the exhaust muffler of your oxygen concentrator is dirty, you can clean it by washing it with soapy water and then use it after drying, or you should replace it with a new one depending on how much your muffler is damaged. Thank you. As it is visible in the pictures also.
Thank you, Kulwinder, for your answer. Any comments from any technicians or any questions from the audience? Okay. Then we will move on to our next question, which is, I am a biomedical technician at a certain clinic. This week, a nurse came in with a complaint that there are droplets of water in the tubing that connects the humidifier bottle to the patient outlet of a certain oxygen concentrator, although the water level in the humidifier bottle was as recommended. What could be the cause of the accumulation of water droplets in the tubing, and how can this problem be corrected? Maui, if you could please answer this question.
Thank you very much, Amapri, for the question. So the condition that you just described is called rain out, and it is a normal occurrence when you are using humidification during oxygen delivery. But this now becomes a problem when the water accumulates too much in the pipes. So normally the water droplets in the patient's outlet oxygen tubing connected to the humidifier bottle occurs due to condensation that happens in the pipe. So this is caused by a temperature difference in the room and the humidifier air traveling through the oxygen supply tube. So if your room is too cold and your oxygen is a bit warmer, or if it's the other way around, then condensation occurs, and then that causes some water to accumulate in the pipes. So to prevent this problem, one of the things that you need to do is you need to regulate the temperature of the room so that it is not too hot or too cold. Otherwise, you get the condensation. So just make sure that the room in which the oxygen concentrator is being used is well ventilated to avoid higher temperatures if it's warm. And if it's cold, then you need to increase the temperature of the room so that it balances up the temperatures, and that will help to prevent the condensation in the pipes. So another thing that you can do is the oxygen concentrator should be placed something like 100 centimeters away from the wall. So, and should not be surrounded by any furniture that can block the air circulation. So if the concentrator is not getting enough air circulation, then it will start to heat up, and that becomes a problem. Another thing that you can do is to make sure that you place your concentrator as low as possible from the height of the patient, so that the water condenses when the water condenses in the tube, it just drains back into the humidifier bottle. So it doesn't have a way of getting to the patient. So always make sure that all your pipes are dry before using them on a patient. Because if you used it on one patient and then you had some water left in there, then it becomes a problem for the next patient. So the negative impact of this is that it becomes uncomfortable for the patient, because you get that water that accumulated in the pipe sometimes might also get to your face if you are using a face mask. So just make sure that you always drain the water in the pipes. Thank you very much, Amapri.
Thank you, Maui, for that explanation. I'm going to make a quick comment, and if anyone else has any other questions or comments, please feel free. I just want to say that there is a product, actually, it's called a water trap, and that is a small piece that fits within the tubing that a patient has. And that water trap, it's like a little section of the cannula or the tubing that collects the water. So it prevents the problem that you're talking about there, Maui, where patients feel that uncomfort because there's water that gets into their mask or into the interface that is on the patient. So that water trap basically does exactly what the name suggests, and it just collects the water and prevents it from getting to the patient itself. And I see that we have a question from the audience. Please go ahead.
It's more a comment from our side. I think another reason for rainout could also be too much water in the actual humidifier bottle. That actually happens quite often, where patients fill that humidifier bottle, too full. That can also be a cause of rainout. Thanks.
Absolutely. Thank you so much for adding that on. Definitely the education component, one on, making sure that the humidifier bottles are filled to the right amount, but also the points that Maui shared with the ventilation, keeping devices away from the wall, Sometimes we see even more in a home care setting where, patients don't want to see the concentrators, so they'll cover them with a blanket. All of these things will affect the potential rainout. So thank you very much for adding that comment in. If there are no other questions or comments, we will move on to the next question. And that is, I was fixing a DeVilbiss 515 oxygen concentrator, which had a low oxygen purity problem by installing sieve beds with a new zeolite, but surprisingly, the relief valve started popping. I installed the same beds in another DeVilbiss 515 concentrator, and there was no popping of the relief valve. What could be the problem? Cynthia, if you would please take this question. Do we have Cynthia? Cynthia, we cannot hear you if you are speaking. It looks like you're muted.
Oh, thank you.
Go ahead.
Thank you, Amapri. It is clear from your explanation that the zeolite sieve beds of 515 oxygen concentrator are not the cause of the relief valve popping. So the very first thing is to check the relief valve itself and the internal parts of the relief valve may have been damaged, causing the relief valve to pop before reaching the factory set pressure. The other point is that the DeVilbiss 515 relief valve uses a spring-loaded mechanism which consists of a spring, disc seal, and a valve. So dirty, damaged seal or valve causes damage to the relief valve, making it to pop before reaching the set pressure. So it's advisable to check if indeed it is the relief valve causing the problem, and also to try to use the valve from another concentrator you mentioned in your question on a concentrator that has a relief valve problem, popping up off problem. Thank you.
Thank you very much, Cynthia. We have a poll with this question, and the poll is, have you changed a relief valve? And while we are waiting for answers to the poll, if anyone has any questions or comments, please feel free to share. Okay, it looks like most people have indeed changed a relief valve. We have a couple of votes for no as well, but mostly it is a yes. And with that, we will move on to our next question. But before we do, I want to just take a quick second and welcome some of the people to this call, as it looks like we have some new joinees. So if you would be so kind as to drop your email address in the chat, we will add you to the emails that go out, as well as the calendar invitation. And this way you can see if we're sharing new videos, you'll get a reminder for this weekly call, and we will be able to share any other information that comes that we look to share that would be relevant for biomedical engineers. And with that, our next question is, I am a biomedical technician working as a trainee at a certain health clinic. I am carrying out preventative maintenance on oxygen concentrators, but currently we do not have an oxygen analyzer which I can use to test the oxygen purity of these oxygen concentrators. There are pressure gauges that I can use to test the pressure at the patient outlet, and also the sieve bed output pressure. If I test the pressure and find out that the concentrators are producing the required pressures, can I conclude that the concentrators are working perfectly? And what is the recommended pressure at the patient outlet? Is it the same for all concentrator models? Paulina, if you could please take this question.
Thank you, Amaprit. Oxygen concentrators use a principle known as pressure swing absorption, which is the PSA. This process is based on the fact that under high pressure, gases tend to be trapped onto the surface of a solid. So in the case of the oxygen concentrators, the compressors produce pressurized air, which is filtered in the molecular sieve. It is the high pressure that makes it possible for the nitrogen gas to be absorbed by the zeolite so that we can have the oxygen-rich air at the sieve bed outlet. When the pressure drops, the nitrogen, which was trapped by the zeolite, is released from the concentrator through the exhaust muffler. To answer the first part of your question, although pressure is an important factor in the production of oxygen, it is wrong to come to a conclusion that an oxygen concentrator is working perfectly by just having the required pressure at the output. The functionality of an oxygen concentrator, apart from the pressure, it also depends on the purity of the oxygen being produced by that particular concentrator. As such, you need to test the purity of the concentrator before you conclude that the concentrator is working as required. This is because the concentrator may be working at the recommended pressure, but the oxygen may be below the recommended oxygen purity. Therefore, in your case, I recommend that you wait until the analyzer is available and test the purity of all the concentrators you are working on before they can be used in the wards. Different concentrator models have different output pressures. For example, the output pressure of the DeVilbiss 515 is 8.5 psi, of the SEP Elite is in the ranges of 7 to 9 psi, and of the oxygen concentrator, the Oxyflow 5, it is between the 6 to 8 psi. So if you're working on different concentrator models, I recommend that you refer to the service manuals of those concentrators so that you should be aware of what the right output pressure for that particular concentrator is. Thank you, Amaprit.
Thank you, Paulina, for that detailed explanation. Does anyone have any questions or comments? And we have another poll here. I think this is a really important question. And the question is, do you have an oxygen analyzer? And while we are waiting for the answers to this, we've talked, I think, on this call several times about the importance of the oxygen analyzers. Some of the commercial analyzers, the most popular ones internationally, are the MaxTech and the Salter Labs that come in different versions. There's a simple analyzer that just does the oxygen purity and outlet pressure, and then there's the more detailed analyzers that have a lot more parameters that they can test as well. However, sometimes those can be quite pricey. So OpenO2 has also developed an open source oxygen analyzer, which measures a lot of parameters and is a more cost-effective solution as you can build it yourself. So as the Oxygen Alliance, we always encourage using oxygen analyzers, and we are happy to help any of our members or joinees of our calls to figure out how to get access to oxygen analyzers, whether they want to buy them or make them. And with that, I am happy to say that we did have most votes for a yes, but there are some no's. So please do reach out to us if you need help procuring or making your own oxygen analyzers. Any questions or comments? Great, then we will move to our next question. I have a DeVilbiss 525 oxygen concentrator. When I measure the oxygen purity, it is showing 60%, and there is moisture in the flow meter. What could be the problem? Tato, if you could please take this question.
Thank you, Amapri. So if more you could share the slide. So the DevilBees 515, the DevilBees 525, it's specifically the drive, it's black in color. It has a design problem of not having one-way valve before the patient outlet. And this allows back pressure created when the concentrator is turned off. So some water is sucked from the humidifier bottle back into the product tank, even the flow meter, and it can even leach up to the sieve beds. So the best way to troubleshoot this problem is to open the concentrator and check if there's like moisture visible through pipes. So though the pipes I'm talking about are the ones you can even see on the graphics where we have the bacteria filter, the blue pipes. So you could literally see like some moisture inside them. So if there's no moisture there, you could as well remove the product tank and try to point the hole downwards, and water might come out from the tank. So this is like a clear clue that the zeolite inside the sieve bed might also be wet. So trying a new pair of sieve beds after draining the water in the product tank and adding a one-way valve before the patient outlet should actually prevent this from happening again. Yeah, thank you, Amapri.
Thank you for that explanation. Are there any questions or comments? If not, we are going to move to our topic of interest. This is where we take a few minutes and go over something that is related to oxygen concentrators, but is not exactly a question. So today's topic of interest will be weekly maintenance activities and a checklist. And this will be done by George. So over to you.
Thank you so much. Every equipment depreciates with time, whether it is being used or not. And this can be caused because of different factors, such as wear and tear, accumulation of dust, moisture, and sometimes when it's being exposed to rain or sun. Therefore, to prolong the life of any equipment, we need to inspect, you need to clean, repair in a planned way. So a preventive maintenance works activities differ from equipment to equipment. Some activity must be done every day. Some activities are done on weekly basis, some monthly basis, others after 3 months, some are done after a year, some 2 years, some even 3 years. So we are going to focus on weekly activities, weekly maintenance activities that are supposed to do on oxygen concentrators, and also discuss about the checklist. So the first activity that is supposed to be done on weekly basis is the most important activity, that's cleaning. So this involves removing all the dust and debris from the external part of the concentrator. Next slide. This is basically that you can see in that graphics. You can see a blower is being used to blow some dust that might be on that oxygen concentrator. So another part that is very important that need to be cleaned every week, it's a gloss particle filter, also called a cabinet filter. For you to do a cleaning on a gloss particle filter, you need to remove it. So if the concentrator is being used, you need to replace with a new one so that you do the cleaning on that filter. So what you do, you wash the dirty filter with soapy water, and then you rinse it with clean water. Then you gently squeeze it just to remove some excess water. Next slide. Next slide. So as you can see in that graphics, where we have a filter, that's an intake filter. So in this case, you can see on your left where the filter is validated. So after cleaning, that's what you can see on your right. So this activity is supposed to be done every week. Another important thing that you're supposed to do cleaning on is a humidifier bottle. And this is another important activity that you're supposed to do. So what you do, you remove the cover from the humidifier bottle, and then you rinse the inside of the container with clean water. And you can even use warm water just to remove any salt that might have started to accumulate inside. Another thing that is supposed to clean the pipes that connects to the humidifier bottle. So if the outlet of the pipe is blocked, you need to use a sharp needle to clean the airways of the pipe. Another thing that you're supposed to do on the humidifier bottle, you're supposed to refill the humidifier bottle with distilled water. And this has to be done every week. Another activity that is supposed to be done every week is a visual inspection. So this aims at ensuring that all parts are present and they are tightly fitted. And also what you do is to check if all the screws are fitted. You check if all the connectors and the tubes are fitted. You also check number of runner hours. So in this case, what you do is you need to record number of hours that at what now at when you're doing the weekly maintenance. Next slide. Next slide. Yeah, so as you can see in the graphics, that's a sample history record. So you're supposed to record a date and you're supposed to record number of hours. And on that, that's where you also include that you have done a weekly maintenance. And at the end there, you're supposed to indicate who did the weekly maintenance. That's for follow-ups. And this also brings us to another important thing, that's a checklist. Next slide. Yeah, so on the checklist, as you can see in the graphics, we have on the checklist, you need to record the dates. This is very important. As we have said, this is a weekly maintenance, so you need to record the date that you have done the maintenance. You need to also record the hours here. You also have to record the flow rate of that concentrator. Another important thing not to miss is the oxygen purity. So you need to record the oxygen purity when you're doing the weekly maintenance. Another important thing is you need to indicate if you have washed the gross particle filter and if you have also cleaned the unit. You can also indicate the status of an alarm and also indicate if you have cleaned the humidifier bottle. And also not forgetting that you have refilled the humidifier bottle with distilled water. So this checklist can be found in service manual for oxygen concentrators. And we also have a generic one, which we can also share with you. Another activity that you're supposed to do, this is on weekly basis, is a function check. So here we're checking the functionality of our oxygen concentrator. So every week you check the purity. So the longer the concentrator runs, the lower the purity gets on the concentrator. So purity of concentrator must be checked in order to avoid giving the patient lower purity losses, because the purity can get dropped at any time due to several reasons. When checking the purity of the concentrator, make sure that the flow meter is adjusted to maximum capacity. That is what it was designed for. So if it's a 10-liter model, you need to adjust the flow meter to 10 liters per minute, so that ensure that the concentrator is tested at the worst case scenario. This is the reason that let's say you have a 10-liter model at 10 liters per minute, you can get 85%, but if you adjust it to 5 liters per minute, you get to 95.6%. So it's very important that you test the concentrator at worst case scenario. That's at maximum rated flow rate. So the purity level that must be above 82% when you test it. That is every week. That is according to WHO. But we recommend anything above 85%. That is good. Another important thing that is supposed to check on the functionality is checking the outlet pressure. So for most of the concentrator, the outlet pressure is set anywhere between 7 psi to 10 psi, and some model can even go up to 20 psi. So when the pressure drops too low, you get the wrong flow readings on the flow meter. And because the flow meter are designed to operate at certain pressure, and then you have incorrect flow rate. When the pressure goes too high, the ball also will drop, because the concentrator puts out more air than the seedbed can produce. So changing patient outlet pressure will give you an indication that there's some problem that you need to work on. That is, it may have to do with the compressor, or it has to do with the seedbed. Another important thing that I have to check when you're doing functionality check is to monitor the compressor. So the compressor produces a fair amount of noise when it is running. So normally the noise that is produced is constant. So when it has run for a certain period of time, it will start to produce a squeaky sound. So when you check that, when you're doing your weekly maintenance, it will give you an indication that this compressor needs to be serviced. Another thing on checking functionality, that is on weekly basis, you need to check the alarm system. So you observe the sound of alarms and even the status of the LEDs. So this will give you an indication that the concentrator is operating normal, or the concentrator needs some attention. Now the question might be, what if the concentrator is not being used regularly? Should we continue to do weekly maintenance? I would say, since the concentrator is just being kept, you need to let the concentrator run for at least an hour for a week, and you follow the procedures that I've presented above. So what are the advantages of doing this weekly maintenance? The advantages are so many. One of it would be that you prolong the life of your oxygen concentrator. So instead of using your oxygen concentrator just for 2 years or 3 years, you can use it for 10 years because you have been doing maintenance. Another thing is that you reduce the cost of corrective maintenance, since you have been observing your oxygen concentrator and you have been doing weekly maintenance. To have a major damage, it won't be a major damage won't be difficult to correct. So you reduce the cost of doing corrective maintenance. Another important thing of doing your weekly maintenance is that you're able to track amount of oxygen that is being produced. As I said, every week you are supposed to check the purity of oxygen purity of your oxygen concentrator. So because you're able to monitor how many oxygen concentrators are giving you enough oxygen, that is 85 or 82% and above, you know how much oxygen you are producing. So this can help to do a cost benefit analysis, say with other oxygen sources. So just like an example, Obin02 by 2022 in December, they fixed about 649 oxygen concentrators. This is equating to about 657,860 cubic meters of oxygen available. That is for a week. And this oxygen is enough to support about 4,607 adults and even 34,553 babies with continuous flow of oxygen. That is for a week. So this could have costed about 7,739,830 US dollars, but it only costed about 96,000 US dollars. So you can see when you do your maintenance on your oxygen concentrators, you are able to save some money that can be allocated to some other activities. Thank you so much.
Thank you very much, George, for that very detailed explanation. I think the members of the Alliance and those that are listening on these calls will hear a lot of echoes in what George is just now saying about the importance of maintenance and the presentation that we had by Ms. Deborah Aloyo. So our goal is always to ensure that maintenance is being done. And I see that we have a question or a comment.
Ricardo Boyson from SleepNet in Cape Town. It is a question, and my question is related to the first part of the presentation. So here's the question. Is blowing dust out the most efficient recommendation when cleaning oxygen concentrators in terms of complying with health and safety protocols?
That is a great question. George, can you answer, or do we have any other technicians that can answer?
I didn't get the question clearly.
Yeah, Ricardo's question was, is blowing the dust off the most efficient way to comply with the health and safety regulations?
Okay. Yes, I would say from what I've come to, I know that's the most efficient way. I haven't come across anything that is to the contrary of that.
Thank you, George. Paulina, can I actually ask you maybe to comment on how you clean off the devices? Because I suspect perhaps the regulatory requirements and standards may be a little bit different in South Africa, where Ricardo is also based, compared to Malawi.
Okay. So what we do when we receive machines here, if we've got a machine that is that's got a lot of dust in the inside of it, what we do is we open the machine and we use a blower to just blow off the dust that's inside, just to make sure that the machine is clean inside. There's no dust. There isn't any dust that could possibly clog the intake filter.
Thank you, Paulina. Ricardo, does that give you the clarity that you were looking for?
Yes, thank you. And maybe a recommendation from my side is, if the dust has to be blown out in a confined space, it may be more efficient and useful to use a vacuum cleaner, a high-powered vacuum cleaner, to rather just suck the dust out instead of blowing it, out of the machine, that may create dust particles going all over the place.
Thank you very much for that suggestion. I think the different technicians here will certainly be interested in trying out different solutions. Do we have any other comments or questions? Okay, then we will move to our next question. And the question is, how can one understand how portable oxygen concentrators and stationary home concentrators work? And this is a question, Kawinder, if you would be willing to take.
Thanks, Anupreet. So, there are important differences between portable and the stationary oxygen concentrators. Although both are designed to provide oxygen therapy to the patients and operate on the same principle, that is pressure swing absorption. The major difference between the portable and the stationary ones, that is the size. So portable may be 5 times lesser weight than the stationary one, and other is the weight. So generally the weight of a any stationary machine, that is more than 15 kg, but in case of portables it is only 2.5 kg, starting from 2 kg. And the other difference is the working modes, oxygen output, and also the main power working options. So we'll start from the power options. Oxygen concentrators that can operate on multiple power sources offers greater utility and flexibility. So some concentrators that can operate on the battery provided with the machine, that are the portable ones. So that can be operated with the battery that is provided with the portable oxygen concentrator. That in case of, if I say regarding Inogen, so that is having a battery that can give up a backup of up to 13 hours at setting of 1, and at the setting of 2 it can give a backup of 10 hours. So that is the battery backup. Otherwise that machine can also be used inside the vehicle, car, or the boat. So it can be charged and used using the cigarette lighter point or the charging point inside the vehicle. Third one is the international power supply that can work from 100 volt to 240 volt AC. So any universal supply in any country. So say in India it is 240 volt, in US maybe 110 volt. So that same adapter can work in any country. So that is a plus point for that. So it can work on all the three supplies, that can be battery, inside the vehicle, and on the AC supply. On the other side, we have stationary oxygen concentrators that only work on the AC power supply. So that is the main difference in the case of power supply options. Other is the oxygen output. So smaller, that portable oxygen concentrators produce less oxygen than the larger stationary concentrators. To reduce the weight and size of the portable concentrators, manufacturers design a significantly smaller oxygen generator. So the small POC currently in the market that produces a maximum oxygen output in the continuous mode, that is 3 liters per minute. So most home oxygen, that is the stationary one, they can produce up to 5 liters to 10 liters of oxygen per minute. So this equates to 2 to 5 times the amount of oxygen per minute more than the portable oxygen concentrators. So this will come in the next point, that is the pulse mode. So oxygen patients requiring 5 or more liters per minute oxygen, so they are recommended to use the stationary ones. So the oxygen supplied by the portable may be insufficient for the patients. So this is the advantage that the stationary has, means using more than 5 liters up to 10 liters. Now the next point, that is the mode. So another consideration for oxygen output is the continuous flow versus pulse flow oxygen. So portable oxygen concentrators use the pulse flow oxygen system to reduce the size and weight of the concentrator. So pulse flow oxygen provides a puff of oxygen during the inhale cycle only. It does not provide oxygen during the exhale to conserve its concentrated oxygen delivery. So the portable oxygen concentrators, they have a breath sensor mounted on the PCB of the machine. And also the other thing that is mounted on the PCB, that is a OCD valve, that is oxygen conserving device. So that helps to deliver oxygen only while the patient is triggering, that is while the inhaling phase. So that is a big difference. But the continuous flow runs constantly during both inhaling and the exhaling phase. So generally, the patient, our breathing cycle, that is, if we inhale for 1 second, then the double time will take, maybe more than double time will take to exhale. So if a patient is inhaling for 1 second and exhaling for 2 seconds, that means once breath cycle will be of 3 seconds, so maximum 20 breaths. So we can say that 20 seconds of oxygen was only used by the patient in the continuous mode, and the 40 seconds that were delivered by the machine in the stationary ones, that is wastage because it was delivered during the exhaling phase. So that is the main difference. So while using the machine that is prescribed by a doctor, so that can be consulted by the individual's needs, but a good care of both the paramount and the equal in order to achieve substantially most of the techniques in maintaining them are the same. So cleaning the filter and keeping in a well ventilated place. That these are the main points that have to keep in mind while using any of the concentrators. So thank you. If you have any questions, please.
Thank you very much, Kulwinder. I think the way portable oxygen concentrators work is quite different while still using the same concept. So I appreciate your summary. And maybe that's something that we'll do as a topic in another call, just to explain in more clinical detail how the devices differently work. Do we have any questions or comments? I'm not sure how familiar portable oxygen concentrators are in all of the countries. Okay, if nothing else, I think we don't quite have time for another question, so that will be our last one for today. I will just ask again if everyone who is newly joining these calls, if you would be willing to put your contact details in the chat so that we can get we can add you to our email list. I'd like to thank you all for joining us on this week's Concentrator Talk. And remember that we will be meeting here again at the same time next week. And if you have any questions, please send them to us in advance through our email at info@oxygenalliance.org, and we will do our best to answer them. Be sure to visit our website, www.oxygenalliance.org, to learn more about the Oxygen Alliance and all of our work. And we also have a YouTube channel where all of the recordings of our previous concentrator talks and oxygen talks are posted. So check that out as well. And please don't forget to subscribe to the channel when you visit. So until next time, have a great week, and we will see you here again in the next session. Thank you, everyone. Bye-bye.